Next we have the switch statement, or we have some statement do while loop, and there are some statements here. So this will display the menu, that is 1 for insert, 2 for delete, 3 for display, and 4 for exit. I will ask the user what is his choice. Okay, so say user enters 1. If the value of choice is 1, what happens is case number 1 is executed. So in case number 1, what I am doing is I ask the user to enter the element to be inserted. Then I take that into item, which is the local variable here, and I pass it to the function insert. Okay, we'll look at this insert function later. Similarly, if user enters choice number 2, I call delete function, then I pass reference to queue. Now both the places here for insert and for delete, both the places I am passing reference. Why reference? Because the changes whatever are going to happen in case of insertion, I add an element, or in case of delete, I remove an element. So those changes are to be reflected back. That's the reason we are passing reference. Okay, and as I said, I have made some arrangement. If there is no element found, I am going to return -1. Okay, so if the return value is -1, I will not do anything. If it is not equal to -1, then I say the deleted element is item. And what is this item? Whatever is returned by the delete function. Last option is display. Okay, so display is going to just display from front till rear of the queue. Okay, and if I enter something more than 4, the function is going to, or this loop is going to, while loop is going to break, and the program is going to terminate. Now these are the functions. So first function is insert function. So the first parameter is pointed to the queue, and second is num, okay, which is the element to be inserted. This is the memory which I have shown here. Okay, now if front and rear I had made as 0, I had initialized it to 0. Now first thing, before inserting, I should check if the queue is full. So how do you tell if the queue is full? If rear is equal to max. Okay, if rear is equal to max, this rear is 0 and max is 3. So are they same? Rear equal to 0 meaning if my pointer, rear pointer, has come over here, that means the queue is full, right? So I should compare if the rear and max size are same. Okay, so rear in our case, it is nothing but 0, whereas max size is 3. So are they same? No. That means the queue is not full, and control comes to this else part. In else part, what I am doing is I have to just enter the element in the first position. Okay, so as you know, the elements are inserted from rear end, that is this particular end. Okay, now what is the value of rear? It is 0. Okay, which rear it is? It is queue's rear. That's the reason I write queue of rear. Why arrow mark over here? Because it is pointer. Okay, so queue's rear is what? It is 0. So I take 0 here. This queue of q is nothing but queue of q. Okay, and then what I'm saying is I'm interested in this particular area of memory. What I'm doing there, say the value of num was 1000, the value of item there in the main program, if it was 1000, okay, then this is 1000. I'm going to save 1000 over here. Okay, so this particular location will be 1000. So 1000 is inserted at the 0th location, and I have entered the first element. So what I should do is I should increment the rear. So this is post increment. Okay, so this 0, it is going to become 1. That means indirectly this rear is pointing to the next location now. And what do I have in the queue? Starting from front to rear, whatever are the elements are the contents of the queue. So front is 0, rear is 1. That means the contents of queue are from 0 to 1, which is only one element. Okay, so this either you can write plus plus here, or you can write the next statement. If you don't want to write this plus plus here, you can write this next statement. As of now, I have just commented it. So this is the insert function. If there is, say, one more element to be inserted, the same process again. Rare, I will check if it is equal to max size. What is rare now? It is 1. So is 1 equal to 3? No. So this message will not be printed. Else part I have to execute. Now q of rare is nothing but it is 1. So whatever element, say now I want to insert 2000. So that is going to be stored at q of 0, which is q of 1, which is nothing but this location. So I save 2000 here and I increment the rare. So rare becomes 2. Okay. So this is how this insertion is going to work. Hope that is clear. Next, let us see how delete function works. Okay. Or before that, let us see how display works. Okay. So display, it takes only one parameter, which is q. That is what is to be displayed. What are the or which is the q which is to be displayed. So I take this local now this is actually a local variable, so another memory location will be created actually, but I will just refer the same. Okay, so first I will check if the queue is empty. How do I check if the queue is empty? If front and rear are same, then I say queue is empty. Okay, now in this case front is 0, rear is 2. That means they are not same, and which means that the queue is not empty. Okay, so front rear not equal, meaning they are 0 and 2. This statement is false, so else part is executed. And what do I have in else part? I have a printf statement which says the element of the queue are, and I just print front. So on the output screen something like this is printed, front is printed because of this. Then I have a for loop in which, so I have a local variable here which is I. Okay, then what will be the value of I? Whatever is queue's front. What is queue's front? It is 0. So that I initialize to I. Basically from front till rear I have to go on printing all the elements. That's it. Those are the contents of the queue. So I initialize I with the starting point, that is front. Front is nothing but it is 0 over here. So I have initialized I with 0. Next I check if 0 is less than, what is q of rare? Yes, it is 2. Okay, so is 0 less than 2? Yes, the condition is true. I should go inside the loop. Here I print these arrow marks, something like this. So on the output it prints something like this. Okay, so that it looks little realistic. It looks like q. I have just made this. Then I should print one integer, that is this %d says that I have to print an integer. What is an integer? It is q.q of I. I is nothing but 0. So q.q of array, which is what? q.q of 0, which is this first value, which is nothing but 1000. So I print 1000. After printing, I is incremented, I becomes 1. See here, I is incremented, I becomes 1. I check the condition. Is 1 less than 2? Yes, the condition is true. I come here. Now I print, now the value of I is 1. So I print q dot q of 1, which is nothing but 2000. So 2000 is, another arrow mark is printed. 2000 is printed. Okay. Next, this is the only statement in the loop. Control comes here. I is incremented. I becomes 2. Control comes here. Is 2 less than 2? The condition is false. This particular loop terminates and the display function exits. Control goes back. Whenever the function exits, all the local variables are destroyed. Okay, so this I is destroyed, and the output what we have is, we have front 1000 and 2000. So these are the contents of the queue as of now. Okay, next we will see how this delete function works. Okay, So for deleting any element, I have taken a local variable which is x, meaning whatever I delete, I just want to return it because I have told the return type is int. So whatever I delete should be returned back. That's the reason I have taken one integer variable x. So there is some memory allocated for x. Next, before deleting, I should check if it is empty. If the queue is empty, then I should display this message. How do I check if the queue is empty? We have already seen this. If front and rear both are same, if the value of front and rear both are same, I should say that the queue is empty. In this case, front is 0, rear is 2, they are not same, so this message is skipped. The control comes to else part. Okay, now I should delete the contents, and deletion from where it happens? From front. So what I do is, whatever is the element at queue's queue, that is queue's queue, and the front element. What is q dot front? Q dot front is 0. That means we are speaking about this particular location. So this is at the front, that is to be returned. So this is nothing but this 1000, which I copied into x. This becomes x becomes 1000. Now once the element is removed from the queue, deleted from the queue, what should happen is I should go to the next element. The front should go to the next element. So I say q front plus plus. Okay, q of front plus plus. So q of front plus plus, that means this 0 becomes 1. So this is as good as first, like the front element now is 2000. This is deleted. Okay, deleted meaning the memory and all is not deleted because this is an array. I am just pointing, I am making the value of front as 1, which is as good as saying that the queue starts from this particular thing. Okay, then I return x. X is nothing but 10. The last statement of the function, what it does is it takes the control back to the place in the main program from where this function was called, and while returning, the local variables are destroyed. Okay, is this destroyed queue? No, because this, we have not created the memory here. This is not local memory. We had q as the reference. Okay, we had q as the reference, whereas this q is created in the main function itself. Okay, so this is not deleted, only x is deleted because x was local. Say you want to delete another element, the same process applies. I check if front and rear are same. They are not same, so this is skipped. Control comes over here. I check the element at front. What is the element at front now? Q of front is nothing but 1. So I return the element, which is 2000. I return. Then the front is incremented. Front becomes 2. And I return that, and that's it. Now for the third time you call delete function, what happens is I come here, I check if front is equal to rear. Is front equal to rear? Yes, 2 and 2. So they are same, which means the queue is empty. So this message is displayed, and I return -1. Okay, -1 I have handled in the main program. You have already seen. If this function returns -1, then if delete returns -1, then what I do is I check if the returned value, which is nothing but item, if it is not equal to -1, I was printing the deleted element. Otherwise I don't do anything. So in this case it is -1. So item returned is -1. I'm checking, I'm saying here -1 is not equal to -1. So this condition is false, and this particular statement is skipped. I break out of switch statement. So hope you have understood the working of insert and delete and display with respect to queue data structure.